All right, just as we graphed sine and cosine, we're going to take a look at graphing y equals tangent x. And I recreated this table one more time. I think it's great to just have this down pat and come up with these values. Tangent, remember, is sine over cosine. We could kind of look at the graph and see what's happening, but in my opinion, like the graphs of sine and cosine, and the fact that we are dividing, but in my opinion, it's just easier to look at this chart and kind of think of the unit circle once again. So, tangent. At 0, we get 0. All right, that's the first point. At pi over 4, we get 1. So pi over 4, we'll just put a 1 here. We get 1. All right, now to think of the values square root of 3 over 3 and square root of 3, got to kind of think what's happening here. I mean, you could just use a calculator, but this is going to be less than 1, right? Square root of 3 over 3 is definitely less than 1 because square root of 3 is less than 3, and we're dividing by 3. So it's somewhere, I'm not going to get a perfect value. I don't really care for the purpose of this video. It's somewhere right there. And you'll see in the big scope of things it doesn't matter. But square root of 3 is greater than 1, right? Because square root of 1 is 1, square root of 4 is 2. It's somewhere in between there. So I don't know exactly, somewhere up here. And then pi over 2 we get undefined. So if you get a calculator and you create a table of values and you check values that are really, really close to 1/2 pi but not quite, what you will notice is that sine is getting increasingly, and we can look at sine and cosine here. Sine is getting increasingly larger up to 1 though, right? It stops at 1. While cosine, on the other hand, is getting smaller and approaching 0, right? It was square root of 3 over 2, square root of 2 over 2. It's getting smaller and smaller until it hits 0. So really what we want to think about is what is happening right here, right? If I had a bunch of tables before I hit pi over 2, a bunch of values. Well, this is getting larger and larger to 1, and this is getting smaller and smaller. And if you take a very large number and divide by something very small, it's getting larger and larger. Right? If we're increasingly getting large and increasingly getting small, then overall we're increasingly getting large. So what that means is this is going to continue. So there's some curvature here, and we could get a graphing calculator and really check, but it's getting increasingly larger, but it will never reach pi over 2 because that's an undefined point. And what happens is we end up getting an asymptote here. Asymptote. Remember, an asymptote just means it's a vertical line, in this case a vertical asymptote, that the graph of tangent will not cross. So what about the rest of this graph? Like, all I gave is this table up here. So we're going to kind of think again of this unit circle, what happens. So at pi over 2, I had y over x, right? Sine over cosine on the unit circle. We had 1 over 0. So let's look at 3 pi over 2. I'm missing a parenthesis there. Whoops. Y over x is negative 1 over 0, again undefined. So back here at negative pi over 2, wherever that is, it's going to be another asymptote. It would be undefined there. And again, thinking kind of pulling at multiple angles here, right? A chart, unit circle, a graph. It's confusing at first. But remembering all students take calculus, these values in this quadrant 2, in this between pi over 2 to pi, are all negative for tangent. So these are all negative from I'm sorry, I'm working pi over 2 to pi, right? I'm thinking in here. But same could be said of 0 to negative pi over 2 because a negative angle is here, right? 0 to negative pi over 2, and only cosine is positive, which means tangent is negative. Using the same reasoning that we did above, how it is increasingly getting larger when we evaluate those values 0 to 1, that's the same that holds here, except they're negative, right? Because we have in quadrant 4, the y values are all negative. We have some positive divided by a negative. So it's still getting increasingly larger, but in the negative direction. So tangent ends up looking, and we could get more of these values in here just like we did in quadrant 1. But instead I'm using symmetry, right? I know these values will be the same coordinate, except for they're going to be negative for y based off of where they land on the unit circle. And this continues to happen at every interval. Anytime we get to the y-axis, I'm going to have something divided by 0 on the unit circle. So pi over 2, 3 pi over 2, right? 5 pi over 2, negative pi over 2, negative 3 pi over 2, and so forth. I will have all of these asymptotes. But the graph continues to follow this pattern. Every pi we get 0, right? At pi we get 0. At 2 pi we get 0. At 0 we have 0. At negative pi we have 0. But then it just follows this pattern, and it has this curvature. You can verify it in a graphing calculator. I really want to know that we understand where it's coming from, though. If you put this in a graphing calculator, you really got to know what you're doing. You first got to be in radians, right? And then you have to know where to look for the graph. Okay, if you're not zoomed in enough or zoomed out too far, you may not see clearly what is happening. It's also important to know where these asymptotes lie. It's important to know at what values tangent gives us a 0. So there's a lot of information we're drawing in to get this graph down. That is the graph of y equals tan x. And so fill in this last little tangent there. Last, let's talk about domain and range. Okay, the domain, we're used to seeing interval notation for domain, but we have a bunch of restrictions, right? Basically, every pi over 2, x cannot equal that. And so how do we write that? So there are a few ways. I prefer this way. X cannot be pi over 2, right? That was our first problem. But then if we add 1 pi, because 1/2 pi, right? And then 1.5 pi, 2.5 pi, they're all problems. But we also cannot subtract a pi, right? If I went back 1 pi or back 2 pi. So again, there are various ways to write this. We could say x cannot be pi over 2 plus n times pi. So any multiple of pi where n is a real number. I'm sorry, n is an integer, or you could say plus or minus n pi where n is a natural number. This little e thing is saying it's within. Basically all counting numbers, right? Again, however you want to list it. If you want to write in words, I'm okay with that as well, as long as you really get what's happening. Any 1/2 pi, any multiple of 1/2 pi, not multiple, I'm sorry, 1/2 pi, and summing some sort of pi, 1 pi, 2 pi, 3 pi, or subtracting 1 pi, 2 pi, 3 pi, is not in the domain. The range, however, negative infinity to infinity, right? It goes forever down, forever up in each of these little sections of tangent.